we are going to look at the idea of vectors. A vector quantity has magnitude, which is size and direction. Examples of vectors are velocity, acceleration, force, and work. So what we want to do is, how do we draw a vector? We're going to look at that. So due south is where you draw straight down in the south direction, and we would put our 30 miles per hour on the vector. Notice it has a magnitude, 30 miles per hour, and a direction, south. 16 feet per second south, 60 west. So we're going to do south and then go west, which is going to be to our left. So we're going to go down and then left approximately 60 degrees. And 16 is our length or our magnitude. We want to find the x and y components of the following vector. So vector is drawn. The vector is actually the hypotenuse of a right triangle. If we draw this with the side along the x-axis, that's the initial side. Here's our theta. So you can see that x is going to be v cosine theta, so magnitude of v, and y is going to be the magnitude of v sine of theta. Okay. So to find the x component, we label it as vx is equal to magnitude of v times the cosine of theta. So Vx is equal to 42. Okay, that should be a 63-degree angle. That angle sign is hard to see. Cosine of 63. So Vx is equal to and we get 19.06. So again, so we're going to say approximately 19 feet. And then Vy is equal to the magnitude of V times sine of theta. So Vy is equal to 42 sine 63. Which is 37.4. So Vy is approximately 37 feet. Okay, magnitude of V at 45 degrees. Vx is equal to 110 cosine of 45. Vy is equal to 110 sine of 45. So Vx is equal to, and again, I'll round to the nearest whole number. I get 77.78, so we'll say approximately 78 feet. And Vy is 110 times sine of 45, which is approximately 78 feet. Now, if we want to, just to see, even with the rounding, if we're close, if we do a squared plus b squared equals c squared, if we use more decimals, it would be a little closer. But the first three digits are the same, so we know that we are correct. Given x and y components, find the magnitude. So what you want to know is this. The magnitude of v is equal to the square root of vx squared plus vy squared. Okay, because this has to do with, again, Pythagorean theorem. And tangent of theta is equal to Vy divided by Vx. So the absolute value of V is equal to the square root of 8 squared plus 6 squared. Not absolute value, magnitude. Magnitude of V is equal to, so let's see, 6 squared plus 8 squared is 100. So the square root of 100 we know is 10. So the magnitude is 10. So tangent of theta is equal to 6 over 8. So theta is equal to tan inverse of 6 over 8. we get 36.86 degrees. So we're going to say theta is approximately 37 degrees. Okay, Vx and Vy, V is equal to square root of 10 squared plus 12 squared. Theta is equal to tangent inverse of 12 over 10. So we have the square root of 10 squared plus 12 squared, which is, so the magnitude of V is approximately 16, if I round. Second tangent, 12 divided by 10 is 50.1, so theta is approximately 50 degrees. Yeah, remember these are coming from the horizontal. A bullet is fired with a speed of 1,600 feet per second and an angle of 45 degrees. Find the magnitude of the horizontal and vertical components. So this is what we have. My angle is 45 here. The bullet is being fired at 1,600 feet per second. So Vx is equal to 1,600 cosine 45. And Vy is equal to 1,600 sine of 45. So Vx is approximately, and if you notice with the sine and cosine of 45, the answers are the same for the x direction and the y direction. So we get 1131.37. So we'll say approximately 1131. Okay, we want the velocity vector. So it's going to be feet per second. And Vy is approximately 1131 feet per second. Now, for our last example, we have a boat that travels 72 miles on a course of a bearing of north 27 east and then changes course to travel 37 miles at 55 degrees east. How far north and how far east has the boat traveled? Now, we're going to approach this a little bit differently. So, east is in the x direction, and west, not at west, I'm sorry, north is in the y direction. North and south are in the y direction, east and west are in the x direction. So, let's see, they're going to go 72 miles, so 72 cosine of 27. Okay, that's your first boat. And then over here it's 72 sine 27. So we're going to add vector components. And then it's going to travel 37 miles, so 37 cosine 55. And this, okay, and this will be 37 sine of 55. So what we want to do is we want to do these values on the calculator. Okay, so basically what we're doing is we're working Vx here and Vy, and then we're going to do V is equal to the square root of Vx squared plus Vy squared. So let me grab my calculator. We have 72 cosine 27 plus 37 cosine 55. We get 85.37. So I'm going to go ahead and carry the decimal point here. 85.375. We're going to go ahead and carry 4 decimal places because I am rounding. So 72 sine of 27 plus 37 sine of 55 is 62.995. So this actually rounds to 63. Okay, so we want to know how far north and how far east the boat has traveled. So we're going to go ahead and say it's going to travel 85 miles east and 63 miles north.